We're going to prove angle pair relationships in this video. And we have two essential questions to take a look at. What can be assumed about angle pair relationships from a diagram? And how are the properties of special angle pairs used? And again, we're gonna see some two-column proofs involving these angle pair relationships. So first example, we're going to prove the right angle theorem. If we know that angle 1 and angle 2 are right angles, that's our given statement. We're going to start our proof out with that. We want to prove angle 1 is congruent to angle 2. So right angles are congruent. So knowing that they're right angles tells us their measurements. So measurement of angle 1 is 90 degrees. Measurement of angle 2 is also 90 degrees. That's the definition. By the substitution property of equality, that gives us that the measurements of the two angles are equal. Knowing that their measurements are equal tells us that the angles are congruent by the definition of congruent angles, and we've proved the right angle theorem. If angle 1 and angle 2 are complements, and angle 2 and angle 3 are complements, what do we conclude about angles 1 and 3? Well, the answer might be obvious to that, but knowing that the measurement of angle 1 plus the measurement of angle 2 is 90 degrees. That's the definition of complements. We know that the measurement of angle 2 plus the measurement of angle 3 is also 90 degrees. Because those are complements, what can we conclude about angles 1 and 3? Well, knowing that these two statements both equal 90 degrees tells us that the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 2 plus the measurement of angle 3. By the subtraction property of equality, we can subtract the measurement of angle 2, and that leaves us with the measurement of angle 1 is equal to the measurement of angle 3. So given our choices over to the side, knowing that the measurements of 1 and 3 are equal, our best answer choice in that list is going to be answer choice A. They're congruent. Another example here, we're given some expressions, some algebraic expressions for the measurement of angles 2 and 4, which are vertical angles. We want to find the measurement of angle 1. Oops. Gave that one away a little early. Well, okay, so the answer is 35. So how do we get that answer? Well, knowing that angle 2 and angle 4 are vertical angles, that means their measurements are equal. So we can set the 15x plus 25 of measurement of angle 2 equal to 17x plus 9, which is the measurement of angle 4. If we solve for x, we can subtract 15x from both sides, and we get 2x on the right plus 9, subtract 9, we get 2x to equal 16, which means x is 8. To find the measurement of angle 1, we look at the relationship between measurement of angle 1 and either the measurement of angle 2 or angle 4. It doesn't matter which one, but let's look at the measurement of angle 2. We know to be 15x, well x is 8, 15x plus 25. Doing the multiplication and the addition gets us that measurement of angle 2 is 145 degrees. Angle 1 is the supplement of the measurement of angle 2, and therefore the measurement of angle 1 is going to be the difference of the measurement of angle 2 from 180 degrees. So that should be the 35 that we knew the answer was. Okay, I'll try not to give this one away before we're ready. Let's see. Measurement of angle 2 equals the expression 10x plus 5. Angle 3 equals 4x plus 7. Find angle 1. Well, in this example, we're given the expressions for a linear pair. So the angle 2 here and angle 3 are a linear pair. So we know that their measurements, 10x plus 5, there's angle 2, and angle 3's measurement, 4x plus 7. We know that they'll add to 180 degrees because they're a linear pair. Combining like terms, 14x plus 12 is 180. Subtract 12, 14x is 168. Divide both sides by 14, and x is 12. So knowing that x is 12, and knowing that we have to find angle 1, well, angle 1 is a vertical angle with angle 3. So if we can figure out what angle 3 is equal to up here, then we have the measurement of angle 1. So we want to do 4 times 12 plus 7, so 48 plus 7, which gives us our final answer, 55. Okay, back to two-column proofs here. Given that ray BD bisects angle ABC, and that ray CA bisects angle DCB, and that angle ABD is congruent to angle DCA, we want to prove that angle DBC, this angle here, prove DBC is congruent to angle ACB, which is this angle here. So we want to prove that those two angles are congruent. Always start out with your given statements. So that's going to be the first line of our proof. Now, knowing that ray BD bisects angle ABC, that's what's going to tell us that angle DBC here, angle DBC, is congruent to angle ABD. That's this angle here. Those are congruent because of the angle bisector, definition of an angle bisector. Likewise, this ray CA bisecting DCB, angle DCB, gives us this statement, and that's that DCA, which is this angle here, is congruent to angle ACB, which is this angle here. So we've got these congruent angles based on the definition. Now we see, based on transitivity, that we have we'll see the flow of transitivity here. If angle DBC is congruent to ABD, well, angle ABD here is congruent to angle DCA, and angle DCA is congruent right here to angle ACB. So by actually 2 steps of transitivity, we've reached our statement we were trying to prove. Angle DBC is congruent to ACB. Okay, another example here. Angles 1 and 2 are complementary. Angles 3 and 4 are complementary. We know the measurement of angle 2 and angle 4, and they happen to both be 24 degrees. Prove angle 1 and 3 are congruent. So, as always, start with your given statements. Okay, we know that measurement of angle 2 is equal to measurement of angle 4 because we're told they have the same exact angle measurement, 24 degrees, based on substitution. If the measurements are equal, that means their angles are congruent. That's the definition of congruent angles. And knowing that angles 1 and 2 are complementary, and 3 and 4 are complementary, we can conclude that angles 1 and 3 are congruent because of the congruent complements theorem. Okay, here's another example. It's not a proof example, but we're simply going to solve for our value of our variable x given the situation and the conditions here. Angle ABF is this angle here. That is congruent to angle AEF, this angle here. We know that the measure of angle CBF is 8x plus 30 is this angle here, and we know that the measure of angle DEF is 12x plus 1. Now because angle CBF and angle DEC are supplementary angles to the two angles given to be congruent, we know that they are congruent. So angle CBF is congruent to angle DEC. Since they're congruent, their measurements are equal, which means 8x plus 30 is equal to 12x plus 1. Subtracting 1 and 8x from both sides, we get x to equal 29/4, and we solve for x. One last example, find the measurement of angle 2 when we're given the measurement of angle 1 is 15x plus 6, measurement of angle 2, 25x minus 75. These two angles are a linear pair, so we know that the measurement of angle 1 plus the measurement of angle 2 is going to equal 180 degrees. So 15x plus 6, here's the measurement of angle 1, plus 25x minus 75 is equal to 180. So we have 40x minus 69 is equal to 180. 40x is equal to 249. And x is 249/40. Now we're finding the measurement of angle 2. So what we want is to substitute 249/40 in for the expression for the measurement of angle 2, and that angle is equal to 645/8, which is equal to 80.625.